22 billion kilometers in over 40 years. That's the distance Voyager 1 has traveled since its launch in the late 1970s. The question is, how far can Voyager 1 travel? Will this probe one day reach a distant star system as humanity's first ambassador? And if so, will we possibly get an answer from there? The Voyager probes are regarded as milestones in space exploration, providing us with never-before-seen images and impressions of the outer planets. That was supposed to be the end of it, but their mission has continued to this day. Can Voyager 1 really fly forever, and what will it see on this long journey? Voyager 1 flies at a speed of around 62,140 km per hour and has long since crossed the boundaries of our solar system. In 2012, Voyager 1 became the first man-made object to leave the heliosphere and enter interstellar space. The identical Voyager 2 probe followed shortly afterward. Since then, the two Voyager probes have been flying further and further into the open universe, each on completely different courses, and nobody knows exactly what they will find there. We cannot predict whether the two probes will one day be discovered by a species that, like us, explores space and is surprised to see alien technical devices. The primary mission of the probes was to explore the outer planets of the solar system. In the 1970s, a unique planetary alignment made it possible to send the probes on an exceptionally short journey to the distant reaches of the solar system. Even back then, there were brilliant minds at NASA who thought it might be possible to send a probe beyond the orbits of Neptune and Pluto toward the Kuiper Belt. This band, over 4.5 billion kilometers wide, is home to billions of rocks, asteroids, comets, and several dwarf planets as we know them today. However, in the 1970s, when the Voyager mission was launched, little was known about this distant region of space. It took the two probes 12 years to reach the outer planets and another 10 years to cross the Kuiper Belt. Nobody knew whether the probes would survive. The risk of collisions with rocks or asteroids was very high, but the two icons of space exploration overcame every problem and every challenge we set for them for 45 years. The Kuiper Belt finally merges into the end of the heliosphere, the area where the influence of our Sun slowly diminishes. Here, the probes were already about 18 billion kilometers away from the Sun. Scientists call this area the heliopause, which is characterized by the separation of solar and interstellar winds. This region intrigued researchers because of its unique properties. When Voyager 1 arrived there, 35 years had passed since its launch. No one would have thought that the Voyager probes would come this far, yet they are still going. As of April 5, 2024, Voyager 1 was 24.39 billion kilometers from the Sun, while Voyager 2 continued its journey at 22.37 billion kilometers. Where will they go next, and what surprises did researchers experience when the most successful probes of all time left the solar system? System shock at the edge of the solar system. It was truly a shock when Voyager 1 was the first of the two probes to cross the final frontier of the solar system. The measurement data it transmitted was very different from what was expected. The transition from the heliosphere to space proved to be like a thick wall, whereas simulations had always predicted a smooth transition, like in a lagoon. The flight through the unexpectedly hard threshold raised new questions about how the interstellar medium is really composed. Until then, all our data about this region had been pure speculation. Shortly after the transition, Voyager 1 delivered real data from open space for the first time, and with it came another surprise. Although the particle density dropped dramatically as expected, there were still more particles than anticipated. This, and a likely different pressure ratio at the transition to open space, is probably causing a buildup of particles and radiation within the solar system, creating a dense wall. Voyager 2 confirmed these measurements when it crossed this threshold years later at a completely different location. There, too, the comparatively hard and abrupt end of the heliosphere was revealed. The heliosphere acts as a kind of protective shell for our solar system, formed by the Sun's permanent streams of particles. It envelopes the star and all its planets in a protective cloak, keeping out harsh interstellar radiation. At this magical threshold, researchers also hope to gain more information about the interaction between the solar system and the rest of the universe. Our Sun is not stationary in space but orbits with its entire system of planets, moons, asteroids, and comets through the Milky Way galaxy. Just like a car moving through the air leaves currents and exhaust fumes behind, our star system must also leave traces in the interstellar medium and interact with it. The Voyager mission is our first opportunity to explore this. Voyager mission. Who would have thought that these two probes would fly forever? Would you have guessed that? These probes could be humanity's longest-lasting ambassadors? Engineers assembled the probes in record time with a minimal budget. Time was of the essence, as a launch window was only open for a few years. The unique planetary alignment allowing for this mission occurs only once every 176 years. The core of both probes consists of a robust, multi-sided structure made of aluminum and titanium, materials known for their durability and resilience against the harsh conditions of space. This strong and enduring construction forms the backbone of the probes and has been key to their mission's great success. The most striking feature of the probes is the large, dish-like high-gain antenna, which has a diameter of 3.7 meters. Like a listening ear, the antenna is always pointed toward Earth. It enables communication over incredible distances, with signals now taking more than 2 hours to travel to Earth at nearly the speed of light. These signals are received by the Deep Space Network, a system of 3 high-performance antennas located in California, Spain, and Australia. The network not only transmits signals from the Voyager mission but is also used by NASA and other space organizations to communicate with distant probes or spacecraft. Whether radio contact with the Voyager probes would continue beyond the Kuiper Belt was uncertain at the start of the mission. The journey beyond the outer planets was a daring adventure, and it is nothing short of a miracle that communication remained stable more than 45 years later at distances exceeding 20 billion kilometers. The Voyager probes have already made history, and their mission will not be topped anytime soon. How far can Voyager 1 travel? You've probably wondered where these two probes will ultimately end up. Perhaps you've even seen the 1979 movie Star Trek, the motion picture, in which a strange superintelligence, VGR, is eventually revealed to be a distorted version of Voyager. This may one day become reality. It is possible that the probe will eventually fly into a distant star system and become stranded on a planet. However, it is far more likely that both probes will continue on their course through open space. Based on their current trajectory, it will take them thousands of years just to pass by the nearest stars. Calculations suggest they could pass Gliese 445 in the constellation Camelopardalis and Ross 248 in the constellation Andromeda. Presumably, the two probes will continue their journey indefinitely until they break apart, which could take hundreds of thousands or even millions of years. No one knows how interstellar radiation and extreme temperatures of -273.15 degrees Celsius will affect their materials in the long term. Over time, particle streams and micrometeorite impacts may erode the metallic components, making them thinner and weaker. The probes were bolted, riveted, and welded in places, and so far, they have withstood all these stresses incredibly well. Experts estimate that at least some parts of the probes will still be traveling through space as recognizable technical components millions of years from now. If humans ever develop faster-than-light travel, we might one day encounter the Voyager probes again, or they could be found by another species. If that happens, the golden record inside each probe would provide an easy way for them to learn who built the probes, how long they traveled, and where they came from. Perhaps, one day, we will receive a surprising message from the universe.